welcome to Drive Live with an Engineer. Today we are joined by Marjaneh Issapour. Marjaneh, also known as Marj, is joining us today from the USA, and she'll be telling us more about a career in the renewables industry, and we'll be looking at the opportunities there, and also in education from an engineering perspective. Marj, great to see you today.
Thank you. Hello, I guess good morning from US, good afternoon for Europe, and good whenever it is for the rest of the world.
Thank you. So Marj, where are you currently working at the moment?
So right now I'm currently working at Farmingdale State College. It is one of the 64 campuses of State University of New York. We're located on Long Island, New York, and we are somewhere between the two major counties, geographically on Long Island, and we serve basically the regional kind of economy in terms of producing the workforce. In our college, we have a School of Engineering Technology, which I'm a faculty at the Electrical Engineering and Technology Department. I also am the Director of Renewable Energy and Sustainability Center at our campus. Hence, you'll see my background, that's a logo. And from that perspective, I oversee the development of many workforce training in the area of renewable that are outside of the college credit-bearing areas and can basically serve different demographic of the Long Island region. And I've also been recently involved with so State University of New York has this initiative on creating and promoting programs, educational programs related to in energy, green buildings, and sustainability. And so from that perspective, I'm the recipient of one of the largest grants from the Clean Energy Workforce Development initiative, and I have started with a group of faculty. I oversee the development of two really timely credit-bearing certificate programs for our college students.
Okay, so Marj, I'm really keen because I'm conscious we're going to have students watching this here, is to tell us more about the opportunities in the renewables industry. I know you've got a slide there you might want to show us so that people can begin to get an idea of how vast that is.
Absolutely. So before I share this slide, I want to tell you that the areas that I've been involved in terms of the curriculum development are, the renewable energies that are very much growing, at least on Long Island in New York, and I'm sure it's really worldwide, right? So the two major industries that are moving really at a very nice speed is solar and wind, right? In our area. And at the same time, there is a push, and I've been very involved with that in terms of with geothermal, and of course, energy efficiency measures, electrification. So if you really think about this, the future is to move away from fossil fuel industry, right? Move into the renewable as our energy sources, which is essentially feeds into our electrical grid, right? So if the whole movement, the economy is going towards getting your energy from clean and renewable sources, then electrification makes sense, right? So then if you're driving an electric vehicle, you are not polluting the environment. At the same time, your source is the electricity that comes from renewable. So having, for example, an electric car in a fossil fuel-based industry doesn't make much sense, right? So, but in the beginning, we need to focus on solar and wind development, right? Because once that's there and our electric sources are there, then we can talk more about electrification in terms of cars and using geothermal, which is a wonderful way of heating and cooling your system, except it kind of involves a heat pump, which uses electricity, right? A little bit. So it all needs to come together. The focus right now is on development of solar industries. So we have on Long Island, and I think in US, and I'm not sure how things are done in Europe, but a lot of these are private industries, right? They're not government, backed companies, right? So it has evolved because people were interested, because things are going that way. So what do we need to do from an engineering, or education perspective is to make sure that we use those opportunities to show our students in engineering in terms of applied learning. So good news is all practicing engineers and all students who are currently studying engineering will have opportunities in this new field. Why? Because the principle of engineering and the way things work hasn't changed, right? We're just getting new sources. But we need to be familiar with particular differences about how these systems operate and what may need to go into the design of them. Correct? So this is what's evolving. So what I want to share with you is focus on wind. Now, why have I chosen wind for today as a focus? Is because New York State our governor has made a promise that a very huge amount of our energy is going to come from offshore wind, right? And that is something that hasn't been at all in our area. So our students are curious, population is curious. Is there a job for me in there, right? Is there a position for me? So, and with that kind of a background, I want to share this slide on which I feel. By the way, this I'm not. Hopefully, there will be a newer study, but this is as good as it gets. This study was done by NREL. Now, NREL is a National Renewable Energy Laboratory. It's one of the national laboratories supported primarily by Department of Energy and Government in US. So they do a lot of good work, a lot of studies. I recommend for students in US to actually take a look at NREL's website. They have done tremendous amount of research and study on all renewables, right? I just picked wind just because that I want to focus that because that's my focus these days, right? But at the same time, I'm also moving towards solar. So they have similar studies, right? Except solar is a little bit more established field in US. So this is a new field. This study was done in 2016, and it's about wind energy as a whole, and not necessarily offshore wind in United States. Now, 249 firms were surveyed. This is a beautiful picture. So nicely color coded, and it tells you all different expertise and all different fields that can get involved in wind, right? So if you look, and I want, again, my focus as an engineer is the second color code here. It's about this kind of a orangish, brickish look. It's 12%. So 12% of the workforce are engineers, right? So if you look at the course catalogs across the United States, you don't see many institutions that offer wind engineering, right? So what is wind engineering? Well, electrical engineers can work as wind engineers in the wind industry because the wind turbines have electrical, mechanical, and structural pieces that go into it, right? They also have things in manufacturing, right? So really all types of engineers, whether you are doing nanotech and you're looking at making blades from a perspective of, making composites that make it lighter and, easier to manufacture, whether you're an electrical engineer that are looking to see how you could make more efficient motors, more efficient generators that changes the mechanical energy to electrical energy, or you are concerned about from the utility perspective, the grids, right? Because these grids have to support a source of energy which is not as constant flow as we had with fossil fuel, right? Different voltage level, different, schemes. So as far as engineers are concerned, this is it, right? Then the only largest segment is 14% by trade workers. So who are the trade workers? These are people that now, again, in northeast of US, most of those trade workers come from organized labor, right? But these are skilled workers. Sometimes they're called blue collar workers, people who lay the foundation, constructions, builders, electricians, right? Huge, huge, huge. So for this group, now I'm going to talk a little bit about me, right? So and then there's 9% of wind technicians, right? So the program that I have recently worked on with a group of faculty in our school, and our college is the first one in the SUNY system, and I believe in Northeast that has a actually, that's not true in the Northeast because I believe that Bristol Community College has a wind technician program. But we have a 1-year certificate program. Anybody from high school or BOCES can walk in. Well, not quite walk in. You have to have some background, right? And interest, obviously. And they will learn the basics of a wind technician, how turbines operate and what to do with them. Now, those courses will also be utilized by our mechanical or electrical engineers, manufacturing and industrial engineers as technical electives. So you become a mechanical engineer with understanding of how wind turbines work. You could be an electrical engineer with an understanding of how they work. You could be a civil engineer and see, those perspectives. And I think the unions and trade workers are also, and by the way, at the same time, our governor has pledged and created an offshore wind training institute with $20 million of funding, just focus on workforce training, which the trades can apply for and use in colleges and universities to expand their educational program. So the will of the government and policy, local policies are there, right? So we just have to make sure that we tell people there are jobs for you and these are the, fields. Construction laborers, attorneys, administrative assistants, all sciences, applied sciences, obviously professors and teachers we need, right? We need accountants and bookkeepers, right? We need developers, people that put money into these things, right? That they develop, these projects, product designers, government employees to see the permitting process and make sure everything works. Communication experts to take what some of our technical people know, translate it so everybody understands. Basically programmers. There's a lot of programming jobs. So computer science people, right? I just want to give you a little, and then there's some new emerging fields, right? So I was talking to Julia Bovey, who works for Equinor and a wonderful colleague, and we were talking about some of the, really easy kind of jobs, not much training. Did you know that we need to have whale watchers?
Yeah.
Isn't that's a field, right? So what do we need whale watchers for? Well, because we want to put in renewable energy, but we want to make sure that we are not, kind of destroying any species habitats, right? So we need somebody to sit and watch with a binocular. If you see that the whales are coming within a certain mile distance, and I'm not going to use numbers because I don't remember them right offhand, and so that the construction will stop, right? Because those waters belong to are habitats for those species. We don't want to disturb them, correct? So whale watchers. Isn't that an easy thing to do for somebody who doesn't know what they want to do? They like to sit outdoors and watch these things. Look, it's not a permanent job, right? But it's a job and get your feet wet. And then maybe you decide, I like to be working up those towers. I like to be working on infrastructure. Or I like to, become an attorney and talk about environmental laws and talk about the laws and legislatures that will make these types of projects grow more, or
Brilliant. I think that's really insightful. Thank you for bringing that information to our attention. Now, I'm really keen to then come back to you, because ultimately this drive live with an engineer is understanding different people's career paths, and what got you to where you are today. Thinking of the students out there watching at the moment and watching on demand, what they need to be doing if they want to pursue a career like yours, and the different options. So Marj, what really first made you think engineering? Why that to start with?
So I believe everybody, again, it's a belief system. Beliefs can be argued and so on. But for me, was the passion I had for mathematics, believe it or not. Not even physics or all sciences, although I was good at all of them. Physics, chemistry was my most favorite science out of all sciences. But math and calculus is what I was really good at. It just came. I'm not going to tell you it came easy, because nothing comes easy. At some point in your life, we all learn everything because everything's easy. But if you start to focus in an area, things do get challenging, right? But I love math, right? So I used to spend time figuring, calculus, or even proofs in geometry way back, like, in high school. I love to be working on proofs, looking at hypotheses, proofs, and trying to figure out ways I would do things, and then going back, to class the next day and seeing the solution unveiled by the teacher or the professor. Used to wake up in the middle of the night, crazy. Not everyone's like me, but figuring out the problem. I solved it, right? But then I would go back to sleep, and the next morning I'll wake up and I forgot. So
that's why the notepad by the bed comes in handy.
That's what it comes in handy. But I was always too lazy to get that notepad, right? but look, and I just want to tell you that there is something about what inherently you are driven to, right? So mathematics for me, it was, right? And then when I started a career in engineering, believe it or not, and I've had, so with biology, I also loved biology, but chemistry was like my first favorite topic of the science. So I wanted it to make a difference, right? And I thought making a difference will be becoming a physician, because I figured a physician can practice medicine everywhere in the world, right? And do things. So that was really my first thing when I thought about college, right? So I did start as a pre-med student with an engineering in mind as a career to fall back on in case I didn't get into medical school. Because in US, most medical schools, you have to have a bachelor's degree in another field, and then you apply. So you don't get into medical school right away from high school, right? So I chose engineering because that was an easy thing. I said, oh, okay, so I can make this. Now, what kind of engineering? To me, electrical engineering lends itself to be closer and more heavily in mathematics than possibly mechanical engineering was, because I felt like mechanical engineering dealt with forces and so on, and it was more like a physics type thing, right? So I said, okay, medical school doesn't work out, I'll become an electrical engineer. I started doing that, and then I want to tell you, so first year, everything's general. When we got to the second year and I took my first circuits course, I started getting more and more into it, to the point that by the time that I was third year in college, I actually never took organic chemistry because that was a requirement. At that point, I was so interested in what I was studying to be an engineer that I kind of said, nah, this is what I want to do because this is where I have the passion for. And that's how things kind of evolved for me to become an engineer. And then I was lucky, I was doing very well in school. I was picked up right away from bachelor's degree by a company back then known as Bell Laboratories, which was one of the hugest employers when I was, and it was really an honor to really like get selected by them and work with them. And I had done my undergraduate at Stony Brook, which is another one of those 64 campuses that I wind up working with. And then for my graduate work, I went to Columbia University Engineering School, and I again want to thank Bell Laboratories for totally supporting that education, not a penny paid from my pocket for my grad work. And I went to one of the best school of engineering in US, probably even worldwide, because I was lucky enough to get hired by an employer who paid my grad school, tuition. And I worked in industry for a while, mainly telecom industry, moved from companies to companies. And at some point I decided this was great, but I needed a change. And I don't know how. Honestly, I don't remember how becoming an educator came into my radar, but I transitioned into academia. And I've been there since as an educator and an engineer. So again, about every 7 or 8 years in my life, I kind of get a little bit bored with what I'm doing and try something different, right? I don't deviate so much, but I deviate a little bit. So I started off as, and then I went into, networking, which was, I don't mean networking like social networking, right? Computer networking. And so while I was an educator, then I focused for a while on networking, and I was instrumental in bringing something, Cisco is a huge networking company. So I was very instrumental in our college becoming a Cisco networking academy. I always worked on collaboration between industry and engineering because I felt that link needed to be always closer, right? So that was another really overall passion. If I want to tell you in a nutshell about my career, is to bring companies that are employers and industries closer to college and college students closer to companies, right? So I've always worked on projects that created that opportunity, right? And so it was Cisco Networking Academy. And then I started really becoming interested in solar. So we had a colleague of mine at our college that was really an advocate of solar energy. He's retired and he introduced me to, solar industries, and things kind of started from then, into the renewable. And I think as I matured in my career and also in my life, the two major motivation and desires became more prominent in my life. One was to do something to make a difference, to leave a good, lasting effect, which being in sustainable energies and renewable energies really lends itself to. The other one was this collaborative teaching and learning environment with industry, right? And so that's what I have done. And, I utilize a lot of, networking from perspective of, dealing with engineers. Like one of the things that I do encourage all the young engineers is when you're in school, depending on the field that you study, there are professional organizations that really offer free or very little membership fees for students. For me, it was IEEE, Institute for Electrical and Electronic Engineers. I know mechanical people have ASME, and other societies. So get involved in those student chapters, right? Getting involved into robotics clubs, things that bring more applied learning into your career. It's very important.
Explain the real importance to that to students listening today. Why is it so critical that they I know that they do this before they leave their education.
Well, because I think we all start with a perception of what, for example, electrical engineering is or electrical engineers do. But what do they really do, right?
Yeah.
So unless you deal with or you physically, socially network with people who do this in day in and out, you don't become intimately familiar with what the expectations are from the perspective of an employer that is out there, right? And you may be sorely disappointed. You know, you may have gone to college for 4 years and studied really hard and got good grades and think, oh, I'm going to walk out of here with the red carpet. They're going to put the red carpet out and life will be perfect. Well, guess what? Life is not perfect. And who better to tell you than somebody who's already gone through that and can tell you, well, what may be some of the challenges, right? Or they can tell you, listen, you're in your third year or second year, you know, and a lot of things are changing into wireless communication instead of wire. So it's important to take this digital communication course, right? And I'm using very specific examples in my field of electrical engineering, right? Or you want to get involved with solar or wind industry, does your college offer a technical elective in that area? If not, can you take an online course in it, right? If not, can you become a member of a subgroup or subcommittee in your professional organization, like IEEE, that deals with those things and become more familiar with what's important in those things and what are the topics that need to be emphasized while you're in college, right? Before you come. And when people interview you, what are they looking for? You know, so this becomes really, really critical, at least in engineering. You know, I'm not sure, and I could guess that it applies to law, and I could guess it applies to anything else. So the second important thing for students is internships, right? Look for internship opportunities, which are opportunities at, I think after maybe the second year in college, some are looking for third year, you know, juniors going into the senior year. Take a summer program as an internship with a company that is in your field. Many opportunities, but you have to start looking for them early enough. You start in October if you're thinking next summer. You don't wait till May to say, oh, I'm looking at internship. Oh, I couldn't find anything, so I'm going to work in a fast food store, right? Look, that may be happens to a certain population no matter how hard you try. I'm not saying that by trying you'll all get it, but I'm saying you need to be in it initially, right? So in the fall of your sophomore year, fall of your junior year, look for internship. Because if I'm an employer, first of all, if I really love you, I'm going to give you an offer right before you graduate, and I'm going to say, I want this guy. You know, I worked with him last summer or worked with her last summer, and I love this person. I want her to come work for us. I want her to join our team, right? Because a company invests the time in you by internship. Frankly, interns can't do much because they haven't had much work experience. So the companies are investing the time. They're paying some engineers to bring you on board, right? During those intern summer months where you're earning money. You're learning, but they're also learning about you. And they may want. So let's say that company cannot hire you because they don't have the capacity, or maybe they had 10 and they can only hire 3. But I'm a different employer and I'm looking at you and I'm going to say, well, look, this person went to work for a competitor last summer. I want her or I want him, right? So internships become very important. And I think those are so important. Now, another topic that's very dear to my heart is trying to increase the population of women and underrepresented, at least in US. I'm not sure how spread around things are in Europe. Again, I have no data, but I know, and for that is where I personally like to take kind of, and I think all my fellow female engineers should and will, by far, to serve as role models, to serve And again, why are those internships important? Because if I take a female under my wing, if I'm working in a company over the summer, taking personal interest in them, making sure they don't fall off the track, making sure they don't get discouraged. And so, you know, encouraging to have engineers so that we can so that the engineering field will represent a stratified, kind of a schema, demographic of the society we live in, right?
Well, we've been very fortunate with the Drive Life Engineer series that we've had quite a few women join us, from petrochemical engineers, medical engineers, as role models. I know who've been very forthcoming and sharing their experience. And as you say, it's not a USA isolated problem. It's a global thing. But then again, that also applies to race and everything, making sure that we're all mindful of systematic racism and things like that, and really representing all of society, so that the problems that we're solving solve everybody's problems, not just a proportion of the society's problems. So Marj, I'd like to talk a little bit about education, because some engineers, student engineers might be studying a mechanical engineering degree, for example, just because they're passionate about mechanical engineering, but they're not necessarily sure that they want to make stuff and go into the field. They might want to be educators, and you chose to make that choice from going from an electrical engineer into academia. Could you share more about why you chose to do that? What the early days of that choice, and what a student might need to do if they wanted to pursue that kind of career path?
So first of all, there are a couple of things, right? I think the first and foremost, you've got to want to make the change. And I think, so let me tell you one of the beauties of becoming an educator, right? I mean, there are many challenges. I'm not going to tell about you. Challenges exist in every field. You just have to want to do things to make things work. But one of the most, for me, kind of a rewarding attributes of becoming an educator is that every day that when you teach and you walk out of the classroom or whatever, you see a reaction, a light bulb that maybe goes on in somebody's face, right? When you're describing things, because you start off with students that don't know much to begin with in any field, right? So you start telling them about the basics, the foundation, the theory, how does this circuit work, or put a problem on the board, right? And you want to help them to go through solving that problem, whether it's a protocol of solving a certain problem or just a procedure, and getting them understand the basics, right? So the basics are not exciting. The basics are just learning, right? So you start putting a problem on the board and you go over it and you look back and you check the reaction of the students in the classroom. And just by looking, you could kind of see, do they look confused? And I mean, you always ask questions. Is there any questions? But nobody asks questions because people feel, oh, it's stupid to ask questions. Well, let me tell you something. I always start my every single semester by saying they could only be stupid answers, not stupid questions. So when you ask a question, I could be the only one that's stupid in this room and not the rest of you. So rest assured and ask questions. But the fact is, sometimes people don't, right? So you look, right? But then there's those aha moments that happen at least once a week, if it doesn't happen every day, where somebody says, oh, I get it. Or you see that smile in their face, or you see, right? So that is so rewarding. Because working for industry is rewarding because you work hard for a project, 6 months, few years, right? Then you go to beta phase testing and project works. Or, I mean, this is again the good moments, right? Forget about challenges, staying up late at night, getting them to work. So, but that happens at the kind of an end phase of a project. For me, in industry, that didn't happen every day or every week. But this aha moment and I'm in a good place and I'm making a difference happens very frequently, right? So if you are a type of person like me that likes to see those mini rewards, like little chocolates every day, as opposed to throughout the day, as opposed to the big dessert at the end of the night or week, then education is for you, right? But I have to tell you, it's not empty of challenges, because for me, and I'm not sure, and I think it has to do with how fast you learn things. So for me, I was a very quick study and fast learner. So I was in for a huge surprise when I started talking about teaching, when I was teaching, and I realized kids don't get it. Not everyone is as fast as I was, right? So slowing down, finding that happy pace of not leaving so many people behind, but then not boring so many people has got challenges. And so I did say that at every about 7 or 8 years in my career, I needed a new challenge and a new change. And this was about that more than, oh, okay, so now I'm going to find new ways of doing this, or I'm going to find a new topic that I can, work around. What are other rewarding things in it, or how do you pave your pathway to education? So first, you have to see if you have the personality for it, and the personality means perseverance. You can't give up. You have to always think that the slowest kid in the class is your beloved child, right? And treat them that way, and be patient with them, right? So you need patience. You cannot be you have to be process oriented and see the progress and be able to receive and give feedback, right? So the feedbacks come in many forms when you are teaching. Again, I talked about reaction, facial reaction, but there are times where you want to stop and tell the students, don't put your name on this piece of paper, but tell me, what was the muddiest point of this lecture? And collect those back without anybody's names on them, and go back at night and see, okay, so my perspective was I thought I did a good job on this topic, but what did they think, right? So if you're not open to opening that dialogue and that sort of a criticism and going back and forth, you won't become a good educator. You'll become an educator. So most engineers are great engineers, but they're not good educators, right? Because if you go into teaching, like high schools and teaching field, people take lessons in pedagogy and how to teach. Engineers don't get that opportunity. We don't even get to have those as tech electives, because our field is full of electives, tech electives, that we don't even get to outside of that, right? So most of us, when we walk from industry, we think we want to teach for whatever, various reasons, right? And we go into teaching, we're really in for a rude awakening. And we need to learn. You need to be open to a lot more learning than you did it back in college, right? So what will help? If right off the bat you're thinking you want to be an educator, in the college, somewhere, take an extra time, take courses in pedagogy and how to teach, because that becomes really important, right? And if research is important to you, then you choose a topic that you're passionate about, so you can get grants. So then you can employ your students to work with you, right? People who are just as passionate. I hope I addressed that question.
That was really helpful. Thank you. So take those courses and learning how to teach, and make sure that you're patient.
Yes.
You can take criticism. Fantastic. Thank you, Marjaneh. Now, I'm thinking, just to wrap this up, reminding everybody who's watching this live, if you've got any questions, do put them in the chat box. If you're watching it on demand, put them in the comments box below. We'll come back to you. Marjaneh is on LinkedIn, so you can find Marjaneh Issapour on LinkedIn and reach out to her that way. Last tips now, Marjaneh. If you were an engineer about to go out and graduate, you were looking to the world of work, what would you do? How would you prepare yourself? I know you've highlighted a few of those today, but some really like key tips that you just want to leave the students thinking about as we wrap up.
Internships, if you had an opportunity to do so. If not, possibly connecting through your professional societies with some engineers who are already in the field. A lot of people, from those professional societies, myself included, are at the point in their career where they want to give back, although they're not teachers. And so they will be glad to connect with you. Obviously, LinkedIn is a great tool to connect with people who are in the field that you want to go into. Many of them are open. I know this summer I got two females that are switching fields into the sustainability. None of them have any engineering background, but they just reached out to me and said, can we talk? And I've scheduled a time. I spoke with them just to see where they're coming from, where they're going, because they wanted to know, they're interested in environment, right? But then their background, they didn't study anything in that, and they wanted to know, are there programs that they can, attend, whether it's in my college or somewhere else. So I try to keep up with what's out there, not just necessarily from my institution, but other institutions. And I know there are many people like me who like to give back. So reach out, ask questions. But again, think early, early meanings again, sophomore year, junior year. And don't be disappointed if you are the top student in your class and you send out 100 resumes and you only get few callbacks, right? So just don't get disappointed. There is a right job for you out there. It needs to be a good fit, not a perfect fit. Your first job is a good fit, is a fit, right? And then once you start working, you learn more about your field and you learn more what it is that you don't like and you like to avoid at your next job, right? And so on. And that's the evolution process in life, right? We evolve as humans, we evolve as engineers. Learning never stops. And I think I could tell you something. If from a perspective, and I've heard this from a lot of employers, from a perspective of an employer, they want to hire problem solvers, not necessarily somebody who's just good at, let's say, wind energy. For example, they're looking more at the person. Can this person become the problem solver, or the critical thinking, problem solving, being curious and asking questions. So if I have one last word for everyone, not necessarily just engineers, never stop being curious. Always ask questions, because that's how we learn. And that's how you grow. And that's how you show to an employer that I'm always thinking, I'm asking questions. So, and again, from our perspective of educators, we don't necessarily want to cover the 100% of the outline that we have out there for every course, right? We're lucky if people remember 10 or 20% of what we taught them. But what is valuable in education is for us to show them and for them to discover how is it that they tackle a problem, not necessarily that they should solve it correctly all the time, but how do you tackle it? That critical thinking process. And that starts by somebody putting a question out there. So there is a problem for you to look into. So you could become that by constantly looking at things. Don't just take anything for granted. Don't accept everything if you don't understand it. Ask. So I guess that's my message.
Brilliant. Thank you. Now I want to swing back to you really quickly, because we call this Drive Live with an Engineer series. And one thing that we ask all of our guests, and we've had 9, 10, I think you might be the 10th guest that we've had now. We ask them, what different vehicles, metaphorically speaking, represent the different points in your career? So I wondered if you might be willing to have a bit of fun now to share with us those metaphorical vehicles for throughout your career.
So when I was a student, I was actually driving my mom's car. So didn't really have my own car. I was sharing my mom. But the first car I bought uh, back then was this small Ford Escort was the car, first new car that I bought. And I actually started payment on that using my student stipend that I was receiving as a grad student, right? So it was quite exciting. I had a new car, but it was a small compact car. It was not a gas guzzler like the rest of the Ford and the Chevys out there, right? So it was the more of a economical choice, right? Because remember, although gas was very cheap back then with respect to the numbers that we see right now, but I've always been a little bit concerned about, um, you know, environment. But I can tell you at that point, environment wasn't even my radar. At that point, it was economy. What can I afford, right? So early on in my, I've made choices that really was economical. Then when I got married and had children, I moved to Toyota Camry. Again, I moved there because I needed a larger car and nothing with that with the gas kind of a type prices and the record of maintenance was available, at the time, in US. So they were coming from Japan, Japanese cars, right? Was great. I loved my Toyota Camry. I had it for 14 or 15 years. And I could still tell you I had many good memories with my children, in the car. And then I think I had two girls at a time. Then I moved to a minivan, Nissan Quest. Again, another Japanese car, very comfortable because I had now three children, right? And very nice, again, good track record in terms of breakdown repairs. Owned that car for a few more years, but then I got into an accident and the car was totaled. So um, then was time to buy another car. So I was doing better financially then than when I started. So I wanted to move again, stay within the cars that had a good repair track. And I love Toyota. I love my Toyota best among all those cars. So I went back to Toyota and I bought a Lexus, right? So I bought an SUV Lexus, which was lend itself to be really, really, really my best car. Um, and I so actually no, in between the Nissan Quest and Lexus, I leased a Mercedes Benz because my dream was always to drive a Mercedes. I don't know. I don't ask me where it came from. Maybe it was just my background, my social economic, whatever. But I didn't buy it. I said, let me try. So I leased the Mercedes 300 E-Class. I loved it, but it wasn't as comfortable as my Nissan Quest or Camry, taking the kids here and there. And that's when I went back to Lexus. I bought a Lexus. So I have stayed with that car. And then I switched to a hybrid Lexus, which is it's a hybrid I have. It's not a plug-in hybrid. It's a hybrid because it saves, it's whenever it stores energy if you're driving downhill and so on. It's a pretty proven technology. Many expect to see me in Prius because it's just like plug-in and stuff, but I have the same range anxiety that many other customers do. But guess what? I've gotten over it. So my next car, which is coming up hopefully this October, will be a fully electric car. Haven't decided which one or what's available at the time, but that would be my next transition. A smaller car and fully electric. Why? Because kids are grown and gone. I don't need that space in the Lexus or an SUV or so on, because you're taking a lot of stuff. But kids are all, in college or have graduated, or actually they're all graduated. And so my next transition would be a fully electric, smaller car. So Prius is one of them. maybe I can afford a Tesla. I'm not sure, but I have to see. But I'm looking, honestly, I haven't made a decision. So those are my transition for fun.
Excellent. Thank you. Thank you so much. And thank you very much for sharing your career journey, your tips to students out there, and your cars, of course, at the very end. We've had no more questions. Somebody did say that their first car was also a Ford Escort.
That's wonderful. Right now, you have to ask them, what are you driving now? I hope you're in hybrid or electric and you're rolling in that direction. Because but I tell you, it was a wonderful car. And by the way, that one also got totaled. That's why I moved to. It wasn't me. It was my husband that got into an accident about that.
You were quick to defend that.
Absolutely.
And quick to blame your husband.
Absolutely. Hey, no. I mean, it was just happening. So I totaled it in the Southwest. So, but anyway, so thank you for giving me this opportunity to talk about my background and hopefully to encourage some young viewers and even not so young viewers who may be transitioning, thinking about, they're practicing engineers and they want to go into wind, or solar or geothermal. There's many opportunities out there that they can take advantage of.
Great. So anybody still with us now, we have got many other Drive Live engineer interviews available to watch on demand, whether you're looking at mechanical engineering, civil engineering, petrochemical engineering, medical engineering. There are many on the Drive Live with an Engineer playlist. You do go back and watch back at those. We do have more interviews coming up. I will be announcing those very, very soon. I believe I have another female engineer lined up to come up maybe next month. So let's see what happens there. It's an ever-evolving thing. If you are an engineer and you're interested in being on Drive Live with an Engineer, please do get in contact with me. My name is Dion Knowles and I'm Term Tech Equipment. You can find me on LinkedIn or you can message Tech Equipment direct on any of our social media channels to reach me. Thank you, Marj. Thank you, everybody who joined us today. Thank you for sharing your Ford Escort stories, and we'll see you again next time.
Thank you.
Thank you.